So hi everyone, my name is Phil. I'm a, I'm a scientific software engineer working at the Met Office. Specifically, I work in the climate monitoring and attribution group, where my day-to-day role is to help the scientists write software to produce and package climate data sets. So these data sets go on to be the inputs for lots of different types of scientific research. So it's really important when writing our data set production software that we write code that is really good. And it's one of the first steps in what I like to think of as the scientific staircase. So we have a lot of these downstairs dependencies from our software. And so when we're writing the code, we really want to avoid a misstep, because that obviously affects everyone who's using the data, can really trip them up. And so to avoid this misstep, we want to follow high quality assurance practices and research software engineering principles. So today I wanted to tell you a little bit about some work we're doing to produce a blended rainfall data set. So this is very much ongoing work, but I'm hoping to offer a few tools and tips that you might find useful in your own data wrangling projects. So the goal here is to effectively blend some recently rescued historic data with current data sources in the context of daily or monthly rainfall. Okay, so where does this rescued data come from? Well, there was this remarkable project a couple of years ago during COVID to digitize past observations from rainfall. So effectively a small army of volunteers from, who had suddenly a lot of time on their hands thanks to COVID, effectively digitized rainfall records that looked a bit like those on the left into useful, parsable CSV files that we could actually now make use of. So thanks to this new downpour of data, we wanted to try and make use of it. And to do that, we wanted to combine it with one of our primary station sources, known as MIDAS. So MIDAS is the Met Office Integrated Data Archive System. MIDAS Open is effectively a large collection of observations from MIDAS that we make public each year. So you can go and have a look at this station data if you're interested. Obviously here we're interested in the rainfall observations, of which there are many. So we have hourly observations, 12-hourly, daily. Depends on the gauge at the station site. And so before we can even blend with this rescued data, which is all monthly, we have to aggregate it in some way to create that before the blending. So the downpour here is that Rainfall Rescue introduces a ton of potential new sites. I say new, they're obviously very old sites from the 1800s and 1900s, but it's very likely that lots of these Rainfall Rescue sites overlap in some way with MIDAS Open. So maybe in location, maybe there's overlapping values that we need to find. And when we generate our new data set that blends them together, we need to make sure that there's no duplication in there at that time. So to solve this problem, effectively, we need some new data set production software. We need something to process the data, standardize it in a way that we can compare the sites and then blend them together. We need to implement some criteria for blending, so looking at the locations, the overlapping monthly totals, the station names, these kind of things. From our criteria, we need to consider how best to blend them and what suitable metrics we can use there. And then we need to, of course, produce a new useful output data product that has traceability back to the original source. Something that's easier for the user to use, but you can always go back and find the original measurements if you want to. Okay, so the setup here is effectively, maybe unsurprisingly, we're developing a Python package to solve this problem. And we're trying to develop it with high QA things in mind. So of course, things like Conda environments, so we're using Conda to manage the dependencies of our project. And specifically, we try to help reproducibility by generating lock files that, a lock file that helps you lock down exactly which package you're using. So if you're using Conda, I definitely recommend looking at Conda lock. And alongside that, we have a whole host of kind of maintainability tools, I guess, that you can use to that really help facilitate the development of the code. So I think in some way, this has something to do with automating formatting and basic checks. And really, we want to enable code review to focus on the complex aspects of the task. So using maintainability tools like this can really help facilitate that. So unfortunately can't go into details about many of them, so do look at the slides if you're interested. I will just highlight pre-commit hooks as a very useful one. If you're get your whole team to use them, it can really help with development. Oops. Okay, so there are just a few ideas for setting up the package. I wanted to talk a bit about how we're tackling the data downpour. So we have Midas Open and Rainfall Rescue. We're trying to standardize, as mentioned before, and I guess the main thing that's difficult here is aggregating Midas Open into these monthly values. And so this is possible, but definitely not recommended to do without extensive testing. And for this, of course, we're using PyTest. But under the hood, a lot of this standardization, in effect, is data manipulation using pandas. So I'm sure if you've used Python in some capacity, you've come across pandas. But what I did want to recommend is that we've actually recently been switching from pandas to using polars. So polars offers a nice API to, oh, how do I get out of this? Oh, sorry, I shouldn't have clicked on that. So it offers a nice API to transform between the data frames from pandas to polars, and you really get a speed increase if you can get your head around some of the syntax. So if you are using data frames, do have a look at that. It's really helped us here. And in general, what we're doing is trying to build our product in a way that's very expendable, maintainable, and modular. So for example, we have an exporter class. We're using different sections of our code. That's been just an example of how we keep maintainability. So station matching, once we have a standardized product and sites that we can compare, we want to look at 3 different types of matching: location, station names, and overlapping values. So just to touch a bit on both. So for location, there is metadata in these 2 original sources, but unfortunately, it's not always high precision. You can't always guarantee the location. But also, the sites are often, especially for the rescued sites, approximations in some way. So, from the 1800s record, there may not have been exactly known which location the gauge was at. And so we need to be able to match in some way potential sites based on a small tolerance. So for this, we've been using spatial indexing. So this is a kind of way of organizing your coordinates so you can very efficiently search only the branches that are necessary. So we use R-tree for this. So if you're doing any kind of spatial indexing or looking at this kind of concept, I recommend having a look at that. And this we found has been really efficient for the station matching process. Of course, one of the key things that we need to do is look at overlapping values. So monthly rainfall, you can kind of think of as a time series. And so I've given an example here where we have Midas Open gauge on the top, a rainfall one in the middle, and then where they happen to overlap is been identified, and then we kind of can look at the difference. And this is an example, a perfect case where you get pretty much exact agreement. So when we go to blend the 2 products together, we don't want to include this duplicated section. We want to remove it and have one single site here. Otherwise, you get double counting and kind of things that affect the grid as well. So finally, we have station names. So we look at location, overlapping values, and station names. This is kind of just an additional check to make sure that our matching is likely doing a good job. The problem with Rainfall Rescue is that it doesn't really have an ID. It has these kind of verbose names that you have to check that they look in some way like the ones that we're trying to blend. So for this, we're using similarity metrics. And the main point I wanted to raise here is that if you have some quite nasty nested for loops in some cases, what we did was just add a number decorated it, and this really sped up our code quite considerably. So that's just another tip I wanted to add. And finally, when we have all these things that we need to consider, we want to look at ways of visualizing different matches. So this is kind of an embedded example of how we're visualizing the matches. For each rainfall rescue gauge, we have the equivalent Midas match, and the location is kind of match is represented as a connection between the 2 nodes. And so we kind of do these things using visualization tools such as PyViz. So kind of in summary, what we're doing is using all of these tools to try to produce a single source product. So as an example, if you use our blended product, you would get a vast increase in historic coverage because, of course, we're including all this historic data. This is really useful for looking at climatology and the aspects of different specific sites. So if we look at this one, for example, the record has been blended successfully, and if you had just used Midas Open, you wouldn't know about a historic downpour back in 1935. So we have a lot of ongoing work with this. Effectively, most of rainfall rescue is not quality assured in the high level that we have with MIDAS. We're kind of exploring a couple of machine learning techniques to look at the unstructured data that comes in the form of kind of comments that were written in the original handwritten documents. So there's a lot of refining that we need to do in the matching criteria. And finally, we want to release the product and code so that people who want to use this single source can always check that things are done correctly, I guess. So thanks for listening. There's lots of links on the slides if you're interested in anything I've talked about. And yeah, happy to take any questions.
Thank you, Philip. We've got a bit of time for a couple of questions. So the first one I've got on Canopy here. Ooh. No, that's the one. The first one I've got is you showed an example of overlapping data where the overlap was good, but did you have any cases where the data didn't overlap in a sensible manner? And what sorts of things sort of lead to these discrepancies between the current and the rescue data?
Yes, there's definitely lots. I think I had to just try to cherry pick a nice one. What we have is, so we have stations, but then stations can have multiple sites. So sometimes you could get a situation where there's slightly different rain gauge measurements at the same time, at the same site, overlapping, but when you do overlapping analysis, you can't link up those sites in a nice way because there's slightly different values. So yeah, it's something we have to consider in our blending criteria and try and work out what is a suitable match. If the location data is there, that really helps. But as I say, there's often a lot of issues with that for the old sites.
Brilliant. I've got another one here from Sarah, which is asking, thank you for the tips on the libraries and tools. Did you make these decisions sort of up front in the project, or did you change the libraries you were using when the performance demanded it? And how complex was the refactoring if it was the latter?
Yes, so actually, Polars I came to know halfway through, and I said the API I would recommend checking out because it's very much a data frame switch, and then it's just about learning the syntax in that new package, I guess. It's a constant consideration. I guess as you want to get it sorted when you start, but yeah, in this case, that was a decision that was made halfway through when the performance kind of demanded it. When we were doing a lot of these aggregations, it was just slow using pandas. So as much as I love it, that was a helpful switch.
And one last quick question following that. We've got a question saying, can you give some kind of idea on what those sort of speed-ups were in absolute terms when you switched the libraries?
So it's in the thousands times kind of fast. So it is quick. So Polars is written in Rust. It's always everyone loves Rust, so it's one of the kind of things that I would say. But the other one is Number increased but that may be due to a nested for loop situation that we can resolve in different ways. But if you don't, then check out Number.
Excellent. If you could join us again in thanking Philip.
Thanks.